Hey GED students, a student on Facebook was working with this problem, simplifying radicals, this is called. So directions for her just said simplify, and I see this radical here. The radical, when I say the word radical, I'm referring to this little check mark house here. Over the 105, so that says, a lot of you guys know that that's that square root symbol. So simplify the square root of 105. Now we have a problem with the number 105 in that it's not a perfect square. Remember what square root means. When I say square root, I'm asking myself, like, what number squared equals 105? And we don't know a number that squared equals 105. We could get close. Like, 10 squared equals 100, or 11 squared equals 121, but we don't know a number that perfectly squares to 105 because it's not what we call a perfect square, which means that we have only two possible ways to do our answer. We could get a decimal approximation, and that's what most y'all's calculators do. Now, I would expect a decimal answer to be somewhere between 10 and 11. Since I got close on either side to 105, it was between 10 squared and 11 squared. I would expect the answer to be a decimal approximation. And in fact, if I were to do it in my calculator, I would get a decimal approximation. But let's look at a calculator to check our work afterwards. Let's simplify by hand. So simplifying radicals really reminds me of reducing fractions. And often we call reducing fractions simplifying as well. You know how with a fraction, we'll leave something as a fraction, but we'll do all the work we can do. Like, for example, if I was simplifying like 3/6, even though I know 3 doesn't divide by 6 perfectly, it is a fraction, I can do some of the math. I can divide out the common factors. If both 3 and 6 have a common factor of 3, and so I divide them out and I get that reduced or simplified fraction of 1/2. Similarly, when you simplify a square root, you're going to pull out any factors that are perfect squares. Even though 105 is not a perfect square, it may have factors that are perfect squares within him. The tool I'm going to use to check a number for its factors is what we call a factor tree. And basically what I do is I just break up 105 into any numbers that are multiplying. I'm pulling it apart into its factors. So I don't know a times table fact about 105, but I do know that it's on the 5 times tables. And I just noticed because it has an end digit of 5. So it has a factor of 5, so I'm going to divide it out to see what the rest of the number is made of. So 105 divided by 5 is 21. Now, 21 also is made of factors. It's made of 3 and it's made of 7. And poor Angie, this is a bad example. I don't know if your first name is, which one's your first name? But anyway, this one's a hard example because it has no perfect squares within it. 105 is made of a 5, a 3, and a 7. Since there's no perfect squares in it, it is simplified. And we can check this in our GED calculator. There's no work to do here. But we can check this in our GED calculator if we're in math print mode. So let's check in a GED calculator. I would not expect you to have to simplify these by hand on the GED without a calculator. I've never seen that, but it could happen, I suppose. So what I'm going to do is I'm going to press mode. I need to be in math print mode, so I'm going to arrow down to the bottom row there where it says math print and overwrite to math print and press enter to select. And now I'm going to press clear to get out of the screen. And now I can check the square root of 105, and when I'm in math print mode, my calculator will simplify rather than giving me a decimal approximation. So you press second, and then the square root button is right above x squared, so you're going to hit x squared, and then you type 105, and enter, and your calculator will say, yes, that's the square root of 105. Check. You did good. Since this one is such a silly example that doesn't simplify, let me do one that does simplify so that people watching this video aren't like, well, that was pointless and silly. Let us simplify the square root of 40. So once again, 40 is not a perfect square. I know 6 squared is 36. 7 squared is 49, but I don't have a number that if I square it will give me 40. And so I have two ways I could get my answer. I could do a decimal approximation, or I can leave my answer as a radical, as simple as possible. And so let's break up 40. This is what I know. Even though 40 is not a perfect square, it has a perfect square within it. 40 is the same as 4 times 10. Now 4 is a perfect square. I chose to break it up that way because 4 is the same as 2 times 2. So that part, just that part, I can square root. The square root of 4, of course, is 2. So the way I think of it is the two that match come out together. The two become 1 if they come out of the square root house. Now, I could keep breaking up 10 if I wanted to, but there's not really a point because 10 is just made of 2 and 5. That's not a perfect square. So I can't square root that part. So it's going to stay behind in the radical. So this is 2 times the square root of 10, or 2 square root of 10. All right, if you have any questions about this, let me know. Drop it in the comments.